Good morning, my dear NEET warriors. Welcome to the 1000 questions in 7 days challenge. And today we are on to the day number 2. I hope you are all excited. After the first day, physics, chemistry, biology, all the top 50 questions being discussed. Already we are 150 questions done. And today you'll be doing more 150 questions. So if you complete day 2, you will already be doing 300 questions. So think about it. Do not waste your time. Now is the time to make sure that you are very serious about NEET. And if you are feeling lazy for some reason, or if you feel that, no, sir, I do not have that motivation, just sit through the class. Okay. The best case scenario is you are solving with us. But the worst case scenario, sir, I have no mood. I don't like this subject. I don't like that topic. Okay, just sit, listen. At least do that. It's okay. Even if you give a wrong answer, that's perfectly fine. Okay, so let's begin with the class, my dear students. Good morning, good morning, good morning. Prema, Pratibha, Muthu, Suchi Mama. Nice to see you after a long time. Hi, Karthi. Welcome, welcome, everyone. Welcome, everyone. Welcome, everyone. Yes, let's begin with the class. Hi, Lisa. Hi, Satya. Nice to see all of you out here. Great, great. Happy morning. Happy morning. By the way, tomorrow my class will be in the night and Nitika ma'am's class will be in the morning. Okay, so there is one change in the timetable from tomorrow onwards. So keep that in mind. But it doesn't matter. You have to still come over here at 11 o'clock. Okay, so let's begin with the class and I hope you have smashed that like button down there. Let me see how many serious students are there. Yeah, come on. Quickly smash this like button. At least in the next 10-15 minutes, make this go 100. And before the session ends, make it go beyond 200. Or else, again, if you don't show the seriousness will not come from the team. I'm telling you, you have to show that you are, because you want to become doctors. We are already teachers. We are set in our careers. We want to make your careers now. Show that seriousness out here. Got it? Great. Awesome. The PDF will be there in the description box as well as in the comments. Don't worry. So let's get ready, Warrior Pandus. Coming up on the screen, the first question. Come on, all the Warrior Pandus, whistle Podu. Oh, we have Krishna over here. Namaste, Sandy. Hi, Siva. Good morning. Christy, Sandy, welcome. Sukanya. Hi, Daredevil. Nice to see you back. Janendra, good morning. Nice to see you too. Okay, work done in bringing a 20 coulomb charge from a point A to B. Distance is 0.2 meter is 2 joules. The potential difference between the 2 points in volts will be how much? See, this is a formula based question. Potential difference is asked. There are many formulas for potential difference, but you can see the work done in bringing the charge from this point to this point is this many joules. So the potential difference is work done to move the charge from one point to the other, the whole thing divided by the charge which has been moved. So you are moving it from one point to the other divided by the charge. That gives me the voltage difference. But if you remember, just the formula for potential at a point was the work done to move the charge from infinity to that particular point upon the charge. That will be the voltage. Voltage difference is from one point to the other, not from infinity. So the work done is nothing but 2 joules. The charge which is moved is 20 coulomb. So this will be 1 by 10, which is nothing but 0.1 volt. 0.1 volt. That should be the answer. So 0.1 is option C, which is C for Captain Shreyas. C for your Captain Shreyas. Correct. Very good, Pratibha. Awesome. Q into V will be work done. Yes, Suchimama, that is also something which you can say. I'm very good, Krishna. I'll tell you honestly, I'm very excited to be in that last phase for your NEET 2025. All these days, I was busy in boards and J, and I was waiting for coming onto the Vedantu NEET English channel for a very long time. Properly, daily classes I want to take now till your May 1st week examination. That's it. Till May 1st week, we are going to be there continuously. And even after that, counseling is going to happen. Okay. So let's begin with the next question on your screen. Electric field due to a dipole on an axial point varies as what power of the distance? What power of the distance? Yes, Satya, C for Capto. Chick, how to score 180 in physics in 2 months? First tell me what is your current score like, then I will tell you. See, simple. If you want to score 180 out of 180 in physics, you cannot leave anything. You cannot leave anything. You need to practice a lot of questions and you need to practice last minimum 10 years of PYQs. Minimum 10 years. Okay. And if you want to push it a little bit further, you have to solve few moderate to easy level of JEE mains PYQs. That will help you a lot. The formula for electric field on the axis is given by 1 by 4 pi epsilon naught. You have the dipole moment over here 2 times divided by r cube. That is the formula. But on the equator, the formula is 1 by 4 pi epsilon naught dipole moment, but it is with a negative sign, whole thing divided by r cube. So always it is 1 by r cube proportional, as you can see. So option B is the correct answer. How many of you said B for Bussosaurus? Yes, B for Capto. Oh, fine. B Capto. Okay, B for biology. Yes, definitely. If you're scoring 90, Muthu, then you need to work really hard because there are a lot of topics you have not covered. 90 means you have not completed the syllabus. Okay, it is not that you cannot say I have watched all the classes. That is not completing the syllabus. You have to see whichever portions are remaining, not done properly, not fully confident. You have to cover them up right now, and whichever portions you have done decent enough, make it stronger by solving more PYQs. So read through the basics. Understanding part will not come through NCRT. NCRT is for by hearting. Lot of people think I can understand things from NCRT. NCRT is probably not a great book for understanding the concepts. It is okay for revising. It is okay for reading. It is okay for seeing what is there and what is not there. That's all. But understanding comes through textbooks like H.C. Verma, Resnick Halliday, or your coaching notes, whatever. An external field of 20 volt per meter induces an electric field of 15 volt per meter in the dielectric. The dielectric constant is how much? Interesting. External field is given. So external field is 20 volt per meter. This is external. What happens is there is an induced field. So the induced field is exactly opposing. So the induced induced opposing field is going to be always 15. It's always going to be opposite. So 15 volt per meter as given in the question. Then what happens is there will be a net electric field. So there will be a net electric field. Obviously that will be 20 minus 15, which is going to be 5 volt per meter. Now, whenever you want to find the net field is your external field divided by the dielectric constant. So it divides by the dielectric constant to give you the net field. So therefore, over here, the value of K will be external field. External is nothing but 20, as you can see, and the net field will come down below over here. What is that net field? It is nothing but 5. The net field is nothing but 5, as you can see. Everybody? So what is the value of K? Yep, the value of K is just going to be 4 units. So 4 is nothing but option A. 4 is nothing but option A. Got it? Yeah. All right. All right. Great, great, great. Okay, chick chick. So guys, I'll do one thing. I'll make a proper strategy. I have to make two strategy videos. One is, see, by the way, uh, let me tell you, in the last couple of days, I had told you in the previous video, I had made a proper video for your, where did it go? Where did it go? Uh, okay, I'm not able to find it right now. Somewhere I had made it. Okay. Anyways, I will make a proper video for all of you for planning your timing, as well as for a proper strategy to score above 170, 160 marks in physics in the last 2 months. Okay. I'll give you both these planners. All right. Cool. Fine. Next, four charges plus q minus q plus q minus q are placed at the corners of a square taken in order. At the center of the square, which of the following is correct? Okay, interesting. So let us start by drawing a square. Let us start by drawing a square first of all. Okay. And the charges are as follows: positive, negative, positive, negative. So positive charge, negative charge, positive charge, negative charge. At the center, what will happen? Let's understand. If you talk about the electric field, the positive charge here will give an electric field like this. This is the electric field due to the positive charge. This positive charge will also give an electric field like this. So that will be in this direction. This negative charge will pull like this. So it will give an electric field in this direction. This negative charge will also pull like this. So it will give an electric field in this direction. Magnitudes, distances are same. So what will happen? The net electric field will be basically a big fat zero, because they will all end up cancelling out each other because of the same magnitude and the same distance. Can you see that? Everybody with me? Yes, you can see that very easily it is getting cancelled out. What about potential? Well, at this point, at this particular point, when you try to find the net potential, it will be due to the positive charge, then due to the negative charge, then positive charge and negative charge. These two and these two form pairs. This will become 0, this will become 0. So 0 plus 0 is nothing but going to be 0. So the net potential will also be 0. Due to the positive, due to the negative, due to the positive, due to the negative, they will cancel. Potential is a scalar quantity, do not forget that. So because it is scalar, direction is not even important. All that matters is the value of the charge and how far it is. That's all. These two things: value of the charge and how far it is. So values are same and distances are same, signs are opposite, they will end up cancelling out each other. So E0, V0, which is option A for Ames Delhi. How many of you got A? Very good, Siva, Karthi, Pratibha, awesome. Kanmani, it is not B. Muthu, very good. Yes, yes, yes. Zinendra, 0E. Yes, Sukanya, very good, Devi. Awesomeness. Perfect. Keep answering, guys. Keep answering. I want full participation in the chat box. Okay. The potential due to a given charge distribution. Yes. Very interesting question. Come on, my dear students. What is the potential due to the given charge distribution? Potential, do not forget, is nothing but the all the sum of all the potentials due to all the charges. So sum means basically integration of all the potentials due to all the charges out here. Do not forget, every charge over here dq at this particular point will give a potential. So the potential due to any 1 point charge on that arc will be given by 1 by 4 pi epsilon naught dq divided by distance, which is basically r. It's just like saying you have a dq charge over here and you are at a distance of r. So at this point, what will be the voltage? Due to a point charge, the potential is kq by r. That's it. Now you just need to bring everything outside. So 1 by 4 pi epsilon naught, 1 by r is also outside. Integration of dq, that is going to be the total charge. That is going to be basically the total charge, which is q. But how much is the total charge on it? How much is the total charge on it? That is the interesting question. See guys, I'll tell you what. In this particular question, this particular arc has a lambda, which is the linear charge density. So lambda is how much charge is there, how much charge is there, how much charge is there per length of that wire, per length of that wire. So lambda will be the charge, total charge on it, upon the length of this wire. Guys, this is 60 degree. So what will be the length? What will be the length? 60 degree is 1/6 of the circumference. It is 1/6 of the circumference. So 1/6 of 2 pi r, which is pi r by 3. Is that correct? It is going to be pi r by 3, because 60 degree is 1/6 of 360 degree. So that is the reason for that. Because 60 degree, is 1/6 of 360 degree. That is the reason why I'm using this number 1/6. Is that clear? Okay, so put the circumference as pi r by 3. Therefore, what will the charge be, guys? It will be lambda pi r divided by 3. Lambda pi r divided by 3. Is that right? Lambda pi r divided by 3. Correct. Very good. So once I got the charge, why not put it over here? Why not put that particular charge over here and see what is it that we get? It will be 1 by 4 pi epsilon naught 1 by r, and we have lambda pi r whole thing divided by 3. Pi r gets cancelled. I will have lambda by pi is gone. 4 threes are 12 epsilon naught. Lambda by 12 epsilon naught. C for Captain Shreyas. That is the correct answer. C for Captain Shreyas. That's the correct answer. So such kind of questions you will not find in NCERT. But is it NCERT based? Yes. Is the theory there in NCERT? Yes. Application part, is it there in NCERT? No. So that is why just reading NCERT is not enough. You have to solve PYQs. You have to go through your coaching modules or your textbooks which are meant for NEET. Because if you just stick to NCERT level, it is not going to make you make marks in NEET physics. Got it, everyone? Yeah. The magnitude is added. Yes, Suchi Mama. Integral dV means dV. Potential due to this, all the charges is added. So in a way, it is adding the potential, but without worrying about the direction because it is a scalar quantity. So I have not taken any components. That's the reason for that. Cool. Lovely question. I hope you enjoyed it. Okay. Next one coming up on your screen. In a charged hollow sphere, shell, hollow, okay, the potential changes with respect to the distance. This is formula based question. If you know it, you know it, or else you will be stuck. So if you are basically somewhere inside, the potential is given by kq divided by r. Now this r over here that I am talking about, that is the radius of the shell. That is the radius of the shell. That means it will be a constant. But the moment you go outside and then find out the potential, it is kq divided by small r, where small r is the distance from the center. So as you can see, it is inversely proportional to r. So it must be a constant and then it should go down like this. So it is going down over here inversely proportional to r, and you can see inside it is basically a constant. You can see it is basically a constant, and this one over here happens to be the radius. So it should be B option, which is correct. Definitely correct. If it was a question on electric field, can you tell me which of the following will be correct? If it was not potential, but it was question on electric field, what will be the answer, my dear warriors? Yes, Suchimama, electric field will be 0. Outside it will be 1 by r square. So then the option will be A if it was for electric field. 0 inside, then it will be 1 by r square. Correct. It will be a curved like that. Good morning, Gokul. Yes, Kanmani, very good. Daredevil, awesome. Too good, yeah. You guys are answering really quick. Very nice. Keep it up. Keep it up. Keep it up, my dear students. Yeah. Very good. Partha, Samantha, Muthu, Jinendra, Tamil Selvi Krishna. Very good, yeah. Yes, A for Ames. Correct. Moving on. Let's go. Let's go. Let's go. Let's go to the next question. If you have identical charges placed at the corners of a cube, okay, side B, then the potential energy of the charges of a charge, basically plus q, which is placed at the center of the cube will be. Okay, so let me just think about a cube now. Um, okay, so I'm just taking up a cube, just making you visualize things. So this is your cube, guys, and there are charges. Which charges are there? Negative charges. Negative over here, 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 negative over here at all the corners. you have taken a positive charge and you have placed it at the center somewhere over here. Now what happens is, if you just imagine this now, if you draw a diagonal, body diagonal from one vertex to the opposite vertex, from this side to that side, okay, exactly opposite, then that particular charge lies exactly on that diagonal which is there for that particular cube, and that charge is at a distance of diagonal by 2 distance from any one of the charge. Visualize the cube, imagine the positive charge at the center, and imagine a body diagonal from one vertex to other vertex. Whatever is the length of the diagonal, half it, that's the distance of the charge from any one of these charges, and in fact any of the other charges also. So the positive charge, this is very, very important. This is very, very important, guys. This particular positive charge, the positive charge is at a distance, equals to whatever is the diagonal, diagonal, by 2 from all the other charges, from all the vertices, where you have the negative charge. Everybody agrees with this? Now, what is the length of a diagonal? What is the length of a diagonal of this particular cube, etc.? It is always root 3 times of the side length. Here, what is the side length? The side length is b. So I'll put b over here, and that's why it will be 2. So always the diagonal is root 3 multiplied by the side length. Keep that in mind for a cube. Correct. Now, you don't even have to use Pythagoras theorem. I mean, you can use it. That's how this comes, in fact. But if you remember the result directly, it will save you that time, 10-20 seconds of applying Pythagoras theorem. So, in general, the diagonal, just keep this in mind, the diagonal, in general, diagonal is the root of L square plus B square plus H square. So, for a cube, what happens? L, B, H are same. So it will become 3 times the side square. So side will come outside and it will become root 3 times. But if the length, breadth, height are different, then it will be root L square plus B square plus H square. Okay, guys, understood? Remember this formula. Don't waste your time in the exam applying Pythagoras theorem. Although that is the correct method, but we have to save our time by remembering certain additional results. Okay, now what to do? We have to find the potential, right? We have to find the potential. So the potential will be the sum of potentials due to all, how many vertices? 1, 2, 3, 4, 5, 6, 7, 8. Due to all 8 negative charges. All the 8 negative charges. So 8 times of potential due to any one charge will be K into the charge. What do we have to find? We have to find the potential energy. Sorry, not potential. We have to find potential energy. So sum of potential energies I should put, not just potential. So sum of potential energies due to all the 8 charges, K, Q, and that other Q, which is again this one over here, but with a negative sign. The whole thing divided by. Understand this Q which I'm talking about, this minus Q, is that negative charge which is there on all the vertices. Okay, each one with this positive charge at the center, divided by the distance. What is that distance? It is nothing but root 3b divided by 2. Root 3b divided by 2. That's it. That is your distance. So solve this, you will definitely get the answer. 8 2s are 16. 16 multiplied by k is 1 by 4 pi epsilon naught. Q into q is minus q square. And this is nothing but root 3 times of b. So how much will this be? 16 by 4 is 4 with a negative sign, q square divided by pi epsilon naught b root 3 times. Okay, just check. Is that option there somewhere? Root 3 is there, 4 is there. Definitely it is there in option number D. Option number D is the correct answer. Got it? So such nice questions, guys, can also come. In fact, not can, it will come. You will see, and you will be then thanking the sessions that we have done on the Vedantu NEET English channel. Because I'm telling you, many channels are not doing good level questions. I don't know for what reason. Either to fool the students, or maybe the teachers only don't know, or maybe you're just not preparing the students hard enough for whatever reasons. Guys, on this channel, we are going to prepare you for the hardest and the toughest paper, because no matter what happens, you have to crack it. Whether you are a low scorer, whether you are a high scorer, doesn't matter. You have to be prepared for the toughest battle. I'm warning this, and then you will thank me for making you prepare for the toughest of the toughest battles. Keep that in mind. Okay, moving on to the next question. Three charges are there: minus q, plus q, minus q, placed in a straight line as shown. If the total potential energy of the system is zero, what is the ratio of these charges? Yeah, Partha, for potential energies, take the sign, because positive and negative will change the value. I mean, the actual meaning of it. Okay, so whenever you are calculating potential energies, definitely consider the sign. Unless you see all the options are positive, then maybe they are interested in the magnitude. So if you see they are only putting positive options, or they mention in the question what is the magnitude of the energy, what is the magnitude of the potential difference, then you give only the positive answer. Is that okay, Partha? All right, Warrior Pandus, what do you think about this particular question? I can see three charges. So I have to take three pairs of charges to measure the total potential energy. Their total, their total, their total potential energy will be potential energy between negative q and negative q, negative q and negative q, potential energy between minus q and plus q, and potential energy between plus q and minus q, which is the same, right? So two times this is coming. Now this total potential energy is given to be 0, so I'll put 0 over here. Between this and this, the potential energy will be k minus q, the whole thing divided by the total distance, which is obviously 2x. Now this has come two times, so I'll put 2 times k. This with this is minus q multiplied by q, whole thing divided by this distance, which is x. Now bring this guy over here, so it will become 2k q divided by x. The negative sign becomes positive. This minus minus also becomes positive. So k divided by 2x. Now a lot of things will get cancelled, like this k, this k, this q, this x, definitely getting all cancelled. So I just have 2 capital Q is nothing but, is that right? 2 capital Q divided by Q by small 2. So therefore, what do we have to find? Small q by, sorry, small q by capital Q. So therefore, I can see small q by capital Q will be equal to, take that capital Q down, 2 2s are 4, 2 2s are 4, 4 is to 1. So 4 is to 1, option number C. Option number C, guys, just check it out. All you have to do is, in this particular question, when you shift capital Q down, this 2 will go on the top. So 2 into 2 divided by 1, which is just nothing but 4. So that is the answer for Q by capital Q. How many of you got option C? Very good, Pratibha. Okay. Some of you made a mistake, I think. They gave answer as A. No, it is not option A. Be little careful. Some silly mistake you would have done while shifting the terms. Remember, this distance is 2x. So that 2x has come here, and this term has come 2 times. Actually, if you see, this is the same thing. So 2 times it has come. This has come 2 times. So that's why that 2, that number 2 has come over here. If you miss this 2, then you'll get the wrong answer. Or if you miss this 2 over here also, you will get the wrong answer. Got it? Very good. Excellent. Shall we go ahead to the next question, my dear students? Okay. Three charges are there at the vertices of a right-angled isosceles triangle. The net electrical energy is 0. Again, find the charge. These kind of questions, very common, guys. Yeah, happens, Sunny. No worries. See, whatever mistakes you make it now. Make 1,000 mistakes, but make it in front of the teacher. Make it in the classroom. Make it at home, so that you do not repeat in the mock test or even in the final exam. What is it? Charge Q, positive Q plus 2Q totally are there. The net energy is 0. Again, the total potential energy I have to take. So the total potential energy will be potential energy between this and this. So it will be K capital Q divided by this distance. Is that distance given? It's an isosceles right angle triangle, and nothing has been mentioned about the side lengths. So let me take this as x. This will be x. This will be root of x square plus x square, which is nothing but 2x square. So x comes outside, so it will be x root 2. So it will be x root 2. Is that right, everybody? Okay, perfect. So what is that the distance that you are taking over here? That will be basically x. Okay, plus between these two, it will be k. What is it? Q, 2q divided by again x only, just like this one. And lastly, between these two, it will be k capital Q small 2q divided by root 2 times of x. So those are the total potential energies, but we know this is nothing but 0. So this will be the same thing. This will be the same thing. So what I can do, I can just bring this guy over here because this total energy is 0. So I'll bring this here minus k uh, 2 times q into q whole thing divided by x. This guy I'm bringing here. So these two people are here as it is. So k capital Q small q divided by x plus 2 times k capital Q small q divided by root 2 times of x. So lot of things will get cancelled now, like this number k, this q and this q, x and x also will get cancelled. So let's see what do we get next. So we have minus 2 q over here is equal to, see, minus 2 times q is there. Here q capital is there, plus here 2q by root 2. 2 by root 2 is root 2. So root 2 times of q is also there. So q can be taken common. So it will become 1 plus root 2, and this will be minus 2q. But what is asked? What is the value of capital Q is asked. So capital Q will be minus 2 times of q, the whole thing divided by 1 plus root 2. So that is what the answer will be. Capital Q is minus 2q by 1 plus root 2, which is B for your Basvasaurus. B for biology. Yes. No, not D. See, D, you will make a silly mistake because you have made a mistake here in this number 2. You have missed that number 2 for some reason. So if you miss that number 2, you will get answer as D. So that is what I'm saying. Chances of making silly mistakes are very high in such problems. It's not like you do not know the theory, you do not know the formula. The moment you make a silly mistake, gone. And make those mistakes now. It's okay, but learn from it. Be very focused. See, when you are going to conduct operations, when you are going to treat patients, when you are going to do research in medical sciences, your life, it's a matter of life and death. So when you can't afford to make mistakes, then how can you afford to make mistakes now? So the practice begins at home. Try to be very focused, concentrated. You cannot deviate your mind. If your mind is disturbed, you are not at peace, all these things will happen. So develop that aptitude, in the next couple of days. You still have 2 months. Cool. Let's go ahead to the next one. The dipole moment is placed normal to the lines of electric field intensity. The work done in deflecting it through an angle of 180 degrees. This is very straightforward, guys. This is very straightforward. Many people will remember some other question and give a wrong answer. But you have to read the question carefully. What is asked, as per that you have to do. The electric dipole, which is P right now, is turned by 180 degrees, whereas the electric field is perpendicular. Normal means 90 degrees. So 90 degrees. So electric field is like this. Electric field is like this. So if you ask me what is the potential energy over here, it is 0. What is the potential energy over here? 0. What is the change in the potential energy? That will be also 0. This is initial, this is final. It will be 0. So therefore, the work done will also be 0. So answer is D. I know why you said P or 2P. No. Read the question, guys, carefully. Read the question carefully. Through an angle, not to 180 degrees. Many of you thought it is taken from here to here, right? Correct me if I'm wrong. You thought first theta is 90, then theta is 180. That's what you thought. Correct me if I'm wrong. So no, no, no. It has been deflected through an angle. So it has been rotated by 180 degrees. So again, the angle will be 90 degrees only. Got it? These are the mistakes. So that's why you have to read the question carefully. It has been deflected through 180 degrees. Be careful. There is another question which you have solved. I have also solved it in front of you. The dipole is in the direction of the field and then it is taken against it from 0 degree to 180 degree. From 0 to 180. For that the answer was 2p if you remember. How many of you remember that question? We have solved it, or you might have also solved it in Tatva or in the assignments, DPP, somewhere or the other. Yeah. So there the answer was 2p from 0 to 180. Here it is 90 to minus 90 or 90 only. So it is not going to change. 90 to 0, 90 to 180, things will be again different. It will be then p. So that's how you have to be very careful. Got it? Awesome. So that is what it feels like. Same, but different. Same, but different. Question feels familiar, but sir, in the exam, I made the mistake. So you have to see what is different and what is same. Two isolated charge conducting spheres of radius A and B produce the same field near their surfaces. Oh, they are producing the same electric field near their surfaces. The ratio of the potentials is interesting question. In general, whenever you have some two things being compared, derive a general formula and then make the final analysis. So if I just if I just consider if I just consider a sphere, let's say the charge is q, let's say the radius is r, then at this particular point, if I ask you what is the electric field on the surface, it will be k q divided by the radius, which is basically r square. If I ask you what is the potential, well, it will be k q divided by r. Okay. Now from this and this, can I uh, somehow relate the two? The two spheres are basically having the same electric field. Oh, so how about getting the value of R from here? Okay, so what I will do, R square will be KQ by electric field. So R will be root of KQ by your electric field. Ratio of the electric potentials to isolated charge conducting spheres A and B, same electric field, ratio of the electric potentials on the surface. Okay. Do I even need to do this? Let me think. If I do this, then I do not know the charge and the charge value, because I do not know, that will create an issue for me. Okay. So let me do one thing. Because it is given to me, the electric field of A is equal to electric field of B, and both the spheres have different radii A and B. Both the spheres have different radii A and B. I can say K charge on A divided by radius of A, which is A only, and K charge on B upon the radius of B, which is again B only. So that is how it will be. K will get cancelled and I will get charge on A by charge on B. A square goes on the top and B square comes below. K gets cancelled, A square goes on the top, B square is below, QB has gone below. So I will get the ratio of the charges at least. And I know potential formula is KQ by R. So if I want to figure out what is potential of A by what is potential of B, the ratio of the potentials, it will be charge of A by charge of B. And then I have radius of B upon radius of A, because it is inversely proportional to radius and directly proportional to the charge. QA by QB directly from here is nothing but A square by B square. Radius is nothing but B by A. BB, AA cancels and I'm left with A by B. So the ratio of the potentials is A by B, which is option number A. Option number A. Wow, such a nice question, right? You just have to play around with the formulas and the ratios. Yes. So what I did in this question was the electric field formula I know on the surface. Since it is given, they have the same field. I equated the fields for both the surfaces and I saw the ratio of the charges is as follows. I need the ratio of the charges here because when I find the ratio of the potentials, radius I know how it is related. Charge may not be the same, and that is why I have taken the ratio of the charges. This value I substituted from here to eliminate the final answer. Got it? Very good. Awesome. Can I say solve HC Verma Lakshana and somewhat easy J means question, but yet my mock test marks is low? Reason I'll tell you, Lakshana, just HC Verma and few J PYQs will not be enough. Solve more NEET PYQs. Solve many questions of NEET level from a question bank. Okay. Number two, you need to develop a testing strategy. Solving at home is different. Slowly, as you progress in the chapter and you have solved average questions and PYQs, you need to develop a testing strategy. Time yourself. In 10 minutes, I'm going to solve 10 questions. Just take a short test. You don't have to sit for 45 questions. 10 minutes, can I solve 10 questions? Oh, I'm not able to solve it. These many mistakes I made. What mistakes I made? Oh, okay. Then again, pick up random. Chemistry, 10 questions I'm going to solve. Okay, what mistakes I made? Then again sit with 20 questions. Then sit with someday 15 questions. Then someday with 30 questions. See what is that breaking point for you. Maybe after 20 questions, you lose your focus. Or maybe after 15 questions, you're not able to think. You are getting saturated. So you need to train your mind accordingly to sit for 3 hours and to think continuously. So that is how testing strategy is slowly developed by timing yourself. 8 drops of mercury, equal radius, possessing equal charges combine to form a big drop. The capacitance of the big drop compared to the each individual small drop is? Well, in these questions, it's always the conservation of volume. You might have seen this in surface tension problems, even many other things, charges, etc., where spheres combine to become a big drop. So 8 drops possessing equal charges combine to form a big drop, meaning the volume has to be conserved. Volume conserved. Volume has to be conserved. So each sphere has a volume of 4 by 3 pi small r cube. There are 8 such spheres. They become a big sphere whose radius is capital R. So that is a volume. 4 by 3 pi cancels. 8 is nothing but technically 2's cube. This is R cube. So therefore 2 times of R is basically capital R. This is the big drop. And these are basically the smaller drops. Okay, so this much part we have got. This much part we have got. Everybody? Yes, volume conservation. Always volume conservation for such questions. That is the standard technique. If you have solved 3-4 questions also like this, right? Immediately it will click. The familiarity will be there in the NEET examination. Okay, now question is on the capacitance. We know capacitance for an isolated sphere is given by 4 pi epsilon naught multiplied by the radius of the sphere. So it's directly proportional to that. So basically the capacitance of the big drop by capacitance of that small drop will be that big radius by that small radius, but big radius is 2 times the small radius, so it will be 2:1, or rather 2 times. So 2 times is the answer. Yes, 2 times is the answer. How many of you wrote C for Captain Shreyas? Many of you said B for bio. No, I know you guys love bio. No, it is not bio. It is 2 times. Is that okay? Everyone loved the question? Amazing. What about the net charge? Very good question. Somebody has asked, sir, what if net charge was asked? Well, each charge will be Q 8 times. So the total charge will become 8 times of Q. This is the total charge on it. This was on the smaller charge. This was on the smaller charge. Sometimes they can ask you potential also. Compare the potentials. Yes, that can also come. So on the small sphere, on the small one, the potential will be K Q by R. And on the big one, the potential will be K capital Q by capital R. And that capital Q will be 8 times of small q. Capital R will be 2 times of small r. 8 by 2 is 4. So 4kq divided by R. But kq by R is voltage at the smaller sphere. So it is 4 times of the voltage. So the voltage will become, potential will become 4 times. That question also comes. Have you solved that question? If you have not solved it, this is it. This can also come and you will thank me later. Thank you, sir. You did this question. Yes, potential is kq by r. Charge will become 8 times. The radius has become 2 times of r. 8 by 2 is 4. But this kq by r is the smaller voltage. So 4 times. Got it, everyone? Okay, great. Let's move to the next question. What does it say? The charge on a capacitor in the circuit in microcoulomb is how much? 4 micro, 4 micro. Okay. So I think to solve this question, you just need to keep on reducing this circuit. So first of all, let me tell you, both of these people are in parallel, and in parallel you just add them. 1 plus 5 is going to be 6 microfarad. So you are just going to get over here 6 microfarad. Yeah, so you're just going to get basically 6 microfarad. Now 6 microfarad can be combined with this 4 microfarad, because now both of them are going to be in series. They are going to be in series. So it will be C1 C2 by C1 plus C2. So 24 by 10, which is 12 by 5. Is that right? Just check it out. 12 by 5 microfarad. Okay. So in the next step, what I will do, this will be 12 by 5 microfarad. Just check this out. Everyone, till this point, clear? Yes. Not 5 by 12. 12 by 5, Suchi Mama, you forgot that 1 by C is also there. So you have to take the reciprocal, usual mistake in parallel circuits or parallel formula. Yeah. Be careful. So C1, C2 by C1 plus C2, that is the formula. So many people forget to take that reciprocal. Okay. So now the question is the charge on the 4 micro. By the way, the voltage is going to be the same. So if it is 10 volts, so on this also the voltage will be 10 volts only. So on this guy, whatever charge will be there. So the charge will be capacitance multiplied by the voltage. So capacitance is 12 by 5. Voltage is basically 10. 10 by 5 is 2. 2 into 12 is 24 microcoulomb. So 24 microcoulomb is there on this. Now you go back a step before. In series, the charges are same. In series, charges are same. So whatever charge was there on the combination, the same charge will be there here also. The same charge will be there here also. 24 microcoulomb, 24 microcoulomb. So 24 microcoulomb will be there even on the 4 microfarad. So when you go back also, this will have 24 microcoulomb positive negative. Now that 24 over here will get distributed. The total charge, the total on this will be 24 microcoulomb. It will get divided in the ratio of 1 is to 5. It will get divided in the ratio of 1 is to 5. Okay, by the way, we just have to find on the 4 microcoulomb. So the answer for that will be 24. On the 4 microcoulomb, it will be 24. But let's say if this guy or this guy was asked, this guy or this guy was asked, then what will you do? Then what will you do? Let me tell you, because Q is equal to CV, Q is equal to CV, both of them are in parallel. So voltage is going to be the same. It is the same in parallel. So charge is directly proportional to capacitance. So charge on 1 microfarad and charge on the 5 microfarad will be in the ratio of the capacitance 1 by 5, 1 is to 5. And the sum of the charges Q1 plus Q5 will be 24 microcoulomb. From these two, can you tell me the total charges? Q1, how much will it be? And Q5, how much will it be? Come on, solve this and tell me. Divide it in the ratio of 1 is to 5. 1 is to 5. Come on, guys. Yes, 4 and 20. Yep, this will be 4 microcoulomb. This will be 20 microcoulomb. You can see that 4 plus 20 is 24. 4 by 20 is 1 by 5. Correct. That is the answer. If this question was additionally asked, 4 and 20. Very good, there. Yes. What will be the charge on 3 microfarad? Very good question. Somebody has asked, sir, what will be the charge on the 3 microfarad? You don't even have to solve this entire question. If 3 microfarad question was asked, then trust me, that is the easiest question. Because you don't even have to find equivalent, nothing. Because already I know this battery is connected across these terminals. So the voltage across 3 microfarad is the 10 volts. So if I have to find the charge on the 3 microfarad, it will be capacitance multiplied by the voltage. Capacitance is 3 micro, voltage is basically 10. It will be 30 microcoulomb. Yes, that I can give it directly without touching this part of the circuit. Because this entire branch, this branch and this, all of them 10, 10, 10, parallel, 10 volts. Isn't this fascinating? Understood? So this is how you should solve problems, guys. And when I solve problems, you might have seen, even in our DNA and NEET Express, whatever batches, we always try to do such kind of things because you guys are so engaged, so interactive. You guys ask me one question, I will create a new problem. And I do not take slides also. Most of the times you might have seen, or even if I have a slide, I make those new questions on the spot so that you learn. And that is how I was able to score almost full marks in my JEE advanced examination. I'm not talking mains. Mains, though, it's fine. I'm talking about advanced examination when I wrote my examination. And that is how my students who implement these things are able to score beyond 170 marks. Beyond 170 marks. That is how it is. Okay. So moving on to the next question on your screen. Two charges, condensers, sorry, capacitors. Condensers, capacitors, same thing. One of the capacity is C, other has a capacity of C by 2 connected to a voltage, both of them obviously in parallel. The work done in charging fully both the condensers. I mean, what is the total effective capacitance? They are in parallel, right? So C parallel, they will just add. So C plus C by 2, that will be 3 times C by 2. So what is the energy stored in that entire capacitance? It will be half the capacitance, which is 3C by 2 into V square. So it will be 3CV square by 4. That is the energy stored in the capacitor. So a lot of people are going to say 3 by 4 CV square. But is that the answer? Is that the answer? Or no? The work done in charging fully both the capacitors. Come on, guys. The work done in charging fully both the capacitors. Now, I'll tell you one small thing is there. If it is work done by the battery, that question is asked. The work done by the battery is always double of the energy stored in the capacitor. So then it will be 2 into 3 by 4 CV square. So 2 and 4 cancels, 2 remains below. So 3 CV square by 2 will be the work done by the battery, if that was the question. But if it is just saying work done to just charge it, that means just to store the energy on it, then the answer will be 3 by 4 CV square. Not mentioned. Battery is not mentioned. Yeah. Is that clear, everyone? So here by battery word is not mentioned. So that is why the answer will not be 3 by 2 CV square. Anyways, it is not even there in the options. But I'm just saying this. But if it is just mentioned how much work is done to just charge it, then you do not count the losses. You do not worry about any resistances. You're just storing the charge slowly without causing any losses. Then how much energy is stored is the total work done. So in that cases, The answer would directly be 3 by 4 CV square. Got it? So yes, it is B option. Sometimes they can give this option also to confuse you. Okay, so I've done both the questions. If by battery word is mentioned, double. If the question was on heat loss, how much lost, how much energy is lost in charging, then always the energy stored is the energy lost. Energy stored is the energy lost. So it will be 3 by 4 CV square. So if battery gives 100 laddus, 50 laddus is stored in the capacitor, 50 laddus are dropped, they are lost. Always remember this example for capacitors. Okay, so when Pandu was asked to carry 100 laddus, Pandu was asked, hey Pandu, give that auntie 100 laddus. What Pandu did? Pandu gave 50 laddus to that auntie, the remaining 50 laddus he dropped it. That is what has happened. He has lost those 50 laddus. So that is how it works. Energy stored and lost is always the same, but what is the work done by the battery? Battery ends up doing double the work, because half of it is getting lost. All right, moving on. Okay, great. All right. Okay. Yeah, we should for work done by the battery, it is charge passing through the battery multiplied by the voltage of the battery or the EMF of the battery. NCRT solutions, yes, few questions will come from NCRT, but just doing NCRT is not enough. Yes, great Krishna. Speed and accuracy, Siva, comes with familiarity and knowing the mathematics and the tables properly. See, speed comes with knowing the tables, mathematical constants, doing the calculations in the rough work properly, and of course, your familiarity, how familiar you are with those kind of problems. If you have done those problems before, similarly, you will be able to remember, I've done this before. You will not waste time thinking. Accuracy is completely different. Accuracy comes by neat rough work, not making silly mistakes, concentration power, and not losing focus, and the stamina which you should develop for the entire 3 hours. This is what develops accuracy. In an adjoining figure, three capacitors C1, C2, C3 joined to a battery, the correct condition will be, oh, come on, guys, this is very straightforward. Come on, come on, come on, come on, come on. Everyone, give the correct answer, guys. Who is in parallel or who is in series? If you understand that, you will get it. See, these two are in parallel. These two are in parallel. That means voltage, potential drop will be the same, but the charges will be different. But that entire thing with this guy, these two together, they are in series, and in series the voltage drop is going to be different, but the charges stored are going to be the same, so on this one the charge is q1. That should be the total charge on this. So the total charge on this will be nothing but q2 plus q3. That is what it will be. So the charges are same. So this charge and this total charge, which will be q2 plus q3. Is it there? Q1 is q2 plus q3. I can see in these two options. So D option and A option gets eliminated. What about the voltages, guys? What about the voltages? Oh, the total voltage. Can you see the total voltage which is there? The total voltage which is there. That voltage is this voltage plus this voltage. This much is V1 and this much is V2. So therefore that V will be V1 plus V2, not V1 plus V2 plus V3. So I think it should be option number C. Yes, that is the correct answer. Yep. In fact, you can see over here, because the voltages are same, V2 will be equal to V3. V2 will be equal to V3. But it is not going to be equal to, V1. Yes. So option number C. Awesome. Awesome. Great, Siva. No issues. I'm here to help you all to make sure that you guys succeed. Okay, so stay tuned on the channel. Make every friend of yours subscribe to the channel. If you're not doing that, you're not giving Guru Dakshina. I've been telling this again and again. So you, whatever you want to learn from the channel, it will stay in your head when you give that Guru Dakshina. So make sure every friend of yours is a part of Vedantu NEET English, the #1 NEET English channel in the country. Correct? Okay. So, uh, Suganya, you're confused about what? See, these two are in parallel. So V2 and V3 will be equal. V2 and V3 will be equal. But this is in series with this. So charges will be equal, potentials will be different. So V1 will be different than V2 and V3. That is what I have told. So V1 will not be same as V2 and V3. But the total voltage will be this voltage plus this voltage. Now this voltage, either you can take it as V2 or V3, one and the same thing. So total voltage of the battery will be this voltage V1 plus V2, or you can also say V1 plus V3, one and the same thing. Is that okay, Sukanya? Perfect. Jinendra, is that clear? You can also write this as, which is V1 plus V3. Why? V2 and V3 are exactly the same. V2 and V3, this voltage and this voltage parallel only, right? So parallel voltages are same. So this voltage, 5 volts plus 2 volts, will be 7 volts. That is what I have written over here. But this and this, even though they are equal, I cannot say it is equal to this. That is not correct, because in series, the voltages are different. So V1 may be different than V2 and V3. Is that fine now? Give me a thumbs up. Got it? Clear? Understood? Yeah. So clear all your doubts, clear all your confusions. That's why you guys are attending live, and that's the benefit of attending the classes live also. All your doubts getting cleared by your master teachers out here. Okay. So fair enough. Moving on to the next question coming up on your screen. Two capacitors C1, C2 connected. Key is open. C1 holds charge Q. After closing the key, the charge on each capacitor in the steady state will be. Okay. Direct, guys. Now what to do in such questions? See, this is open right now. This guy has no charge, no charge. Whereas this capacitor has some charge. How much is it? Q. Q amount of charge is there. Some Q amount of charge is there. Now what happens? You close the switch. Let me show the new circuit. So the charges will definitely get redistributed over here. This is C, this is 3C. So now that charge will get distributed here like this. We have to find the charge on each capacitor in the steady state. I know one thing, this diagram, whatever I have drawn, is similar to just one single diagram of one capacitor. C and 3C are in parallel, if you realize. So it will be nothing but 4C. The reason is both are in parallel. In parallel. So 4C has come because I have to just add the capacitance to find the equivalent capacitance, the equivalent capacitance. And that equivalent capacitance will still store the same charge, will still store that particular charge of Q. Is that right? So what will be the voltage across this? What will be the voltage across this? The voltage across this will be charged by capacitance, which will be charged by 4C, which will be charged by 4C. That same voltage will also be there here. That same voltage will also be there here for both these capacitors in parallel. In parallel, the voltages are going to be the same. Yes, sir. What to do now? The charge on this guy. Okay. So charge on capacitor C will be the voltage into the capacitance. What is the voltage? I just got it. Q by 4C. What is the capacitance? It is just C. So how much will it be? Q by 4. Got it? It will be Q by 4. Similarly, what is the charge on this capacitor labeled 3C? It will be again voltage difference into the capacitance. Voltage difference we already got. Charge by the capacitance. Capacitance is 3C. So CC cancels. So 3Q by 4. In fact, if you add both of them, you will get the original charge. Because the same charge got split. It got split into both these capacitors. So if you add these charges, 1/4 and 3/4 will give you the total charge. So Q by 4 and 3Q by 4 is the correct answer. Got it? Now these kind of questions are very common again, where a capacitor is charged and it is connected to another capacitor. Then find the new charges, find the new potential, find the energy lost, find the energy stored, compare the initial to the final energy. Common question. Solve this 100%. What all? Uncharged capacitor charged to a charged capacitor. Charged capacitor charged connected to another charged capacitor but of a different voltage, different charge, different capacitance. 100% you should be solving it. What is the new charge? What is the new capacitance? What is the new voltage? What is the new energy? What is the ratio of old to new energy? What is the difference of the energy or the energy loss? Common models of question. Okay, so I have shown you one type. You can solve many more such types. We will bring more types in the days to come when we solve more mock tests and more problems during the due course. Cool. How to know whether it is in parallel or series? Just see this diagram. Just see this diagram. Whatever voltage is here and here is the same. So when voltages are same, it is in parallel. As simple as that. So whenever voltages are same, don't go by the looks. Looks are deceptive. Don't judge a book by the cover, they say. Same way, don't judge. Sir, after this capacitor comes, it looks like in series. No, no, no. Don't look at it like that. See, what if I draw like this? This is open. This is open. Now it looks like in parallel. Now, if I just draw two wires on the sides, but it is not connected anywhere, now it feels, yes, sir, now it is in parallel. So, looks are very deceptive. Don't go by that. Just see whatever voltage will be here because it's a wire here, wire here. This point, same potential. This point, same potential. There is a voltage difference, voltage difference. Same voltage difference is always true in parallel. In series, it is the charge which is the same and they are connected one after the other. Siva Prasad, without calculation, I mean, then you have to divide the charges in the ratio of the capacitance. You have to remember many special cases. Don't remember so many special cases. You don't have that bandwidth and you will get confused. Rather, solve it. It will just take you 1 to 2 minutes, not more than that. And you need to get these questions by solving, or else chances of making a silly mistake are very high. And see, whatever you're saying might work when one of the things is uncharged. What if this is charged? What if the positive plate is connected to the negative plate? What if the plates are similarly signed? So all those cases are there. So whenever you solve it, better to do by diagrams before, after. And whenever such questions come, always uncharged capacitor connected to charged capacitor, a capacitor connected to another capacitor, find the final voltage, charge, etc. Always these two capacitors will be in parallel. Keep that in mind. So always you end up adding the capacitance to find the total capacitance. Okay, keep this in mind. Capacitors join. Okay, you charge a capacitor, you charge this capacitor, join it. They will always be in parallel. Keep this in your mind. Okay, guys, fine, clear. Shall we go ahead to the next question then? All right, let's go. What is it? A air-filled parallel capacitor capacitance when a dielectric medium of constant K is introduced to fill half of the space between the plates as shown, the capacitance becomes 2C. What is the value of K? Well, see guys, you can treat this like two capacitors. They are like this. They are in parallel. In parallel. This will be C by 2. This will be C by 2. And now what you have done? Now what you have done? In halves, one of the halves, you have added a dielectric medium. Okay, exactly half of it. So this will become K times of C by 2. And now, whatever is the total capacitance, which will be C by 2 plus Kc by 2, that is given to be 2 times of C. So that is given to be 2 times of C. That's it. That is the simple working diagram for this problem. CCC gets cancelled. So 2 is equal to half plus K by 2. Multiply by 2. This will become 4 is equal to 1 plus K. So take that 1 on the other side. So it will become 3. So K is basically 3. That is the answer. Is that okay? Everyone? Yeah. What if positive with negative? So then if it is positive and negative, it's just that the total charge will be the, let's say one charge is 3q, other charge is minus q. So 3q minus q will be 2q. So the total charge of the system will be 2q. So you add up with the signs. Is that okay, Daredevil? Moving on to the next one coming up on your screen. In the diagram shown over here, the potential of 1200 volts is given to point A and point B is grounded. What is the potential at that point P? Okay, direct guys, I'll tell you what you can do. First of all, can you see both of them are in parallel? You just add the capacitances 4 plus 2, which is basically 6 microfarad. Okay, so I will redraw the diagram. I will just redraw the diagram now. I'll just redraw the diagram. This 4 and 2 is just becoming 6. That will make it easier. Oops. 6 microfarad. Okay, perfect. Now you have to find the potential at point P, but to do that, what we need to do is figure out either what is the voltage here, drop here, or voltage drop here. Now that we can do if we can combine them together to find the equivalent capacitance. So obviously both of them are in series. Both of them are in series. So in series, the effective capacitance will be C1 C2 by C1 plus C2. So 6 3s are 18 by 9, which is basically 2 microfarad. So let us redraw the final diagram now. So this is 2 microfarad, and it is clearly mentioned that the voltage at point A is 1200 volts. This is grounded, that means 0 volt. So the charge which will be developed over here, the charge which will be now developed over here, correct? How much charge will be developed? Charge is voltage difference multiplied by the capacitance. Voltage difference is 1200, capacitance is 2 micro. 1200 into 2, 2400 micro. 2400 microcoulomb. Is that right? 2400 microcoulomb. Everybody with me? Okay. So when you are in series, both the capacitors will have the same charge. So there will be 2400 microcoulombs, 2400 microcoulombs over here. So now come back and figure out what will be the voltage difference over here. What will be the voltage difference over here? So that voltage difference is nothing but the charge by the capacitance. Charge is 2400 micro. Capacitance is 6 microfarad. Micro cancels. 24 by 6 is 4. So 400 volts. 400 volts is the voltage difference. So if this is 0, this will be 400. So C should be the correct answer. So C should be the correct answer. Got it? How many of you loved this particular question, my dear students? Did you love this particular question? Okay. Moving on to the next one coming up on your screen. Here it is. The charge on 4 microfarad capacitor in the given circuit is, I think this just got repeated by mistake. We should not have come. Sorry, guys. This question we have already done. My bad. Okay, next question. The charge deposited on the 4 microfarad capacitor in this particular circuit. It is slightly different. Check this out. These two are in parallel. Their combination is in series with this. Okay, come on, think about it. What will you do? Think about it. Okay. So first of all, these two, what has happened? These two are in parallel, and in parallel you just add the capacitances, so it will be 6 microfarad. So it will be 6 microfarad. Now you can replace them with one single capacitor of 6 microfarad. Now these two are in series, as you can see. Obviously these two are in series. So in series, the capacitance will be C1 C2 by C1 plus C2. So 36 by sorry, yeah, 36, correct, by your 12. So that is just going to be 3. So 3 microfarad. Perfect. So that is the total equivalent capacitance. That is your total equivalent capacitance. So this is not needed. 3 microfarad. Now the question is, on the 4 microfarad, how much charge is there? So go reverse now. Exactly. Go reverse. So on this, how much charge will be there? So the charge will be voltage difference multiplied by the capacitance. Voltage difference is 12. Capacitance is 3 micro. So it will be basically 36 microcoulomb. 36 microcoulomb. Yes. Now you go back in series, the charge is the same. Charge is going to be the same. So if that is the case, whatever charge I got, 6, where is it? 36 microcoulomb, that will be the same on both of them. So this will also have 36 microcoulomb. This will also have 36 microcoulomb. Yes, both of them will have the same charge. Then go reverse. That 36 will get distributed here. The total charge on this, the total on this was 36 microcoulomb, and it will be now divided over here because the voltages will be the same. The potential difference is going to be the same. So the charge is directly proportional to the capacitance. So the charge on 4 by the charge on 2 microfarad will be 4 divided by 2, which is 2:1. Also, the charge on 4 plus charge on 2 totally will be 36. Totally will be 36, divided in the ratio of 2:1. Divided in the ratio of 2:1. Come on, my dear students. How much will be the charges? Quickly tell me the answer. Q2 and Q4. How much will it be? 2:1 divided into 3 parts, 12 and 24. So basically this will be 12 microcoulomb. This will be 24 microcoulomb. 12 plus 24 is 36 and 24 by 12 is 2. Yes, that's the answer. Very nice. Yes, Daredevil. That's the correct one. So that is how you solve these questions. Now, if you are used to solving this multiple times, then it becomes easy, or else you will keep thinking in the exam. See, even though it is a very simple series parallel problem, it is a lengthy problem. You have to first combine the capacitances into a single capacitor. Then you have to again go reverse also. You have to again go reverse also. Keep that in mind. Okay. Moving on to the next one. Okay, check this out. Find the voltage at point B. See, again, very similar question came just some time back, but things are slightly different over here. Things are slightly different over here. Find the voltage at this particular point B. Okay, what will you do over here? No current will be going 100%. There is battery over here. There is 10 volt over here. Then there is 5 volt voltage difference over here. And then there is another capacitor over here. One thing is for sure, whatever charge is there over here, the same charge is there over here. This capacitances are same. So whatever voltage drop is here is the same voltage drop over here also. Same voltage drop here also. So let's say there is some positive, negative, positive, negative. I've just put some charges over here. All right. So the same charge, same voltage, because why is the charge same? Because they are in series. Can you see that? They are connected one after the other. That is why the charges should be the same. The charges should be the same. No current flowing, correct. Voltages are also same. You know what? I feel we should apply Kirchhoff's law. Yes, how many of you thought that we should apply Kirchhoff's law? No? Well, we should apply Kirchhoff's law starting from ground to here. You can go. So you can say, using Kirchhoff's voltage law, from one point to the other point, the potential at the ground plus, here you are going across the capacitor, so there is a voltage drop or increase of delta V. From here to here, positive to negative, I am going downwards, so -5. Here I'm going from negative to positive, so it's a jump. So plus delta V. What when I finally reach here, the total voltage at the destination, that is going to be 10 volts. So that is your voltage at the final destination. Destination. That is how this particular law will work. Voltage at the ground is always zero. Delta V comes two times. So 2 times delta V is there. Minus 5 is voltage at the destination, which is basically 10. So 2 times of delta V is basically 15. So delta V is how much? 7.5 volts. So voltage difference is 7.5 volts. So that's it. That's enough for me to solve the problem. I'll tell you how. At this particular point, the voltage is 0 volt, and I know the voltage difference is 7.5 volts between point B and this. So naturally, at this particular point, how much voltage should be there? It should be 7.5 volts, because this delta V is 7.5. So 0 and 7.5, the difference is 7.5. So 7.5 is option number A. Loved the question. Very nice question, isn't it? Yes, very good, very good. Moving on to the next one. The reading of the ideal ammeter as shown in the network at steady state is steady state ammeter reading. How much will it be? The best part is that there is a capacitor, so there is no current, because capacitor blocks the DC current completely. So there is no use of this branch. There is no current here. So just focus completely only on this much part. Only on this much part. That is exactly where your current will be going. And in that part, the resistance which is there is only this guy and this guy. So in series, so 10 plus 5, which is 15 ohms. So the current, which will be the total voltage by the equivalent resistance, total voltage 30, resistance is 15. So it will be 2 amperes. So that same 2 amperes is going to flow through the ammeter. Hence 2 amperes. I think the voltage, it's given in voltage. That is wrong. Let me just correct it, guys. Currents are always measured in amperes. Same thing over here too. Yeah. So this should have been amperes. That's correct. That is basically 2 amperes. Understood? Beautiful concept. Capacitor will block the current. Capacitor never allows any current to flow through it. Correct. Moving on to the next one. Cell of internal resistance R is connected to an external resistance. Maximum power delivered by the cell. This is maximum power transfer theorem. Maximum power, maximum power transfer theorem, which says that when internal resistance is equal to external resistance, the power is going to be maximum. So that's it. What is the maximum power is asked. So obviously over here in this particular case, the total resistance, the total equivalent resistance will be R plus capital R, which is R plus small r, which is going to be 2 times of R. So power is asked. So power is the total voltage square by equivalent resistance. So V square by 2R. But the voltage is nothing but E over here, and equivalent resistance is 2R. So E square by 2R should be the answer. I think they have made a mistake over here. Maximum power delivered by the cell. Oh, outside they have asked. Sorry, guys. The, my bad. My bad. So the power which is there in that particular load delivered, which is delivered to that particular load, is going to be I squared into that resistance. The current will be nothing but the voltage by the total resistance, which is going to be 2R. So this will be whole square multiplied by R. So this will be E square by 2R whole square multiplied by R, which is again R. So therefore this will be E square by 4R. E square by 4R. So power delivered to the load was asked. So it should be option B. Yes, option B. Very good. Awesomeness. Loving the answers, loving the questions. Moving on, guys, to the next question on your screen now. If each resistance in the figure is 9 ohms, the reading of the ammeter is interesting. So all these four parallel resistances. So parallel means the resistance will get divided by the number of resistors 1, 2, 3, 4. So each figure 9 ohms. So 9 by 4 ohms. Even these. This is 4. 1, 2, 3, 4, 5. So this will be 9 by 5 ohms. Okay. Now once this is done, this is 9 by 4 ohms, that is 9 by 5 ohms. What is the reading of that particular ammeter? Now, if I measure the total current in the circuit, whatever current will be there, some part will go here, some part will go here. Whatever part goes here will come through the ammeter. If you ask me what is the total effective resistance of that particular circuit, it will be 9 divided by 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 resistances are there. So it will be basically 1 ohm. So if you ask me what is the current in that entire circuit, it will be 9 by 1, which is 9 amperes. 9 amperes of current, 9 amperes of current will be going in that entire circuit. Now, think of the circuit to be like this, where you have this as 9 volt, this as 9 volt. Okay. Here you have one resistance. Here you have another resistance. This is your 9 by 4 ohms. This is your 9 by 5 ohms. This current which is coming through like this of 9 amperes will now get divided into two branches. Yes, it will now get divided somewhat here and somewhat here. Yes, somewhat here and somewhat here. So what will those currents be? That current reading is what you are going to see. Yes, that same current, this same current, whatever is going to go here will also come over here also. And that is the reading which you are going to see. So if this is, let's say I1, let's say this is I2, I1 plus I2 will be total current of your 9 amperes. And currents are inversely related to resistance in parallel. Do not forget, in parallel, voltage which is IR is going to be the same. So current is inversely related to the resistance. So I1 by I2, I1 by I2, I1 by I2 will be this by this. So it will be 9 by 4 by 9 by 5. So it will be basically 5 by 4 ratio. It will be basically 5 by 4 ratio. So what is then the value of I1 and what is the value of I2 from these two? Obviously, I1 is going to be 5 amperes, I2 is going to be 4 amperes. So the current which is going to go here, that is going to be I1, because that is the same current which is going to go over here. So that value of the current I1 is 5 amperes, which is option A. Beautiful question. Yes, 5 amperes is the answer. Great. Moving on to the next question on your screen. Thousands of cells of EMF E and same resistance are connected in series in the same order without external resistance. The drop across 399 cells is found to be. Very important, very interesting. They are connected in series, meaning something like this. One cell, one cell, one cell, like that. They are connected one after the other. This is a very famous problem, and the problem goes like this. No matter which 2 points you take, no matter which 2 points you take, okay, no matter which 2 points you take, always the voltage drop will be zero. Okay, always. Remember this very famous problem when you connect batteries one after the other, okay, like this. You take any 2 points, the voltage drop is always going to be 0 because the current in the circuit will be total number of batteries EMF by the total resistance. So it will be just E by R. So whenever you take voltage difference between any 2 points, E minus IR. So it will be E minus I is nothing but E by R into R. So RR cancels, E minus E will always be 0, no matter where you go. So any 2 points, the voltage drop will be 0. Current is total voltage by total resistance, E by R. Voltage difference is E minus IR. No matter where you take it, always every battery has a 0 voltage difference. So 0 volt, 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 0 volt. Everywhere it's 0. Chumma these numbers are given to scare you. The answer should be a big fat 0. Got it? So this is another famous problem. If you know it, you get it easily, or else it will be time consuming or you will waste your time thinking about it. For a given conductor, the drift speeds at 1, 2 and 3 are. Okay. In this entire thing, the current is the same. So the current is going to be the same, but area is different. And we know current is Vidya. Current is same, N is same, E is same. So drift speed is inversely proportional to area. So obviously we can see now 3 has the largest area, then 2, then 1. So A3 more than A2, more than A1, more than A2. So exactly opposite for drift speed. So drift speed for 3 will be less than drift speed for 1, less than drift speed for 2. So V2 should be more than V1, should be more than V3, which is C option. Yes, it is inversely related. Current is NVIDIA. Okay, is that clear, everyone? All right. Nitya, which problem? This problem or the previous problem? I guess you are talking about previous problem. See, these are batteries which are of same EMF, same resistance connected in series in the same order without external resistance. That means no other resistance is there. They are connected one behind the other. So 1, 2, 3, 4, 5, 6, 7, 8, like that. 399 and then 400. So such 400 batteries are there, or I don't know, thousand, sorry, thousand cells are there, 999,000. So what will be the current? Total battery is EMF by total resistance. NN cancels E by R. If you take any battery is voltage difference, it will be E minus IR. That is standard formula for terminal voltage. E minus IR. E is E, I is from here, you get 0. So you take any battery, the voltage difference is 0. So if you go from one battery to another battery also, it will be 0. Because if I say this has 0 volts, this has 0 volts, this has 0 volts, voltage difference. So you go from here to here, 0. You go from here to here, 0. Here to here, 0. So any points you take in that circuit, the voltage drop will be 0. Is that okay, Nitya? Next. Two identical non-ideal batteries are connected in parallel. Consider the following statements. The equivalent EMF is smaller than either of the two. The equivalent internal resistance is smaller than either of the two. Direct question, guys. Come on. Everybody should be able to get it. Clear? Very good, Partha. Nitya, clear? Awesome, awesome, awesome. Okay. What about this? Okay. Two identical non-ideal batteries connected in parallel. Obviously, EMF is smaller than the either of the two, not necessarily, because remember the EMF in parallel is given by E1 by R1 plus E2 by R2. It's some weird formula, 1 by R1 plus 1 by R2. So you cannot say EP is smaller than E1, EP is smaller than E2. You cannot say that. But this one definitely you can. This is 1 by R1 plus 1 by R2. Definitely this resistance is less than R1. It is also less than R2. This is also less than R2. But nothing such can be said over here because of this complex nature. Even if you do analysis, it can be more or less anything. So it's wrong to say about A but B is definitely correct. B is definitely correct. B is definitely correct. A is wrong. As you can see, this is your statement labeled B. Yeah. Okay. Okay. So you cannot tell anything about EP over here. That is wrong to say. EP may be more than or less than E1 or even E2. You cannot say anything because of this R1 and R2. You cannot say that. Next, two resistors are connected in series in an electrical circuit. The thermal energy in R and 2R are in what ratio? Thermal energy, guys. Come on. Thermal energy. Two resistors are connected in series. So if they are connected in series 100%, the current will be the same. Current is going to be the same. So the question is on the thermal energy are in what ratio? So power in the first by power in the second will be I squared R by I squared 2R. R cancels. So 1 is to 2 ratio should be the correct answer. Yes, option number A, that is correct. Very good, Siva. Awesome. This was very straightforward, right? Moving on. Next question on your screen. The resistance of a wire of a cross section A and length L is R ohm. Resistance of another wire of same material, same length, but cross section 4A will be how much? Ayo, come on, this is very easy. What is resistance proportional to, inversely proportional to? What is it, guys? Come on. Yes. Resistance is directly proportional to length and inversely proportional to area and directly proportional to resistivity. Here, this and this are going to be the same. It is given in the question. Same material is given. Same material means same resistivity. Length is also same. So if the area of cross section is now different, area of cross section is 4 times, obviously the resistance will become 1/4 times. So B should be the correct answer. Inversely proportional. Area becomes 4 times, resistance becomes 1/4 times. B for biology. Yes, correct. Very good. Directly. Moving on. The equivalent resistance of the following infinite network of resistance between A and B. Between A and B. Oh, they have not even asked the value. They are just asking whether it will be more than 4 or less than 4, equal to 12, more than 4 but less than 12. Come on, guys. Come on, guys. Think and tell. You have to either sit and calculate it or you can apply some logic. See, I'll tell you one thing. Do you see from point A till here, there is already one 2 ohm resistance, and between this point and this point, there is already one 2 ohm resistance. Now, if you consider this point and this this entire circuit, this is some new circuit, let's say I call it R infinity. It will have some resistance of its own, that is secondary. But what is important is between point A and B, you already have this, and this. So when I try to find the total resistance between A and B, it will be 100% that 2 ohm plus 2 ohm plus this one, which is in series, R infinity, because all three of them are one after the other. One, two, three resistances which are in series. So for sure, can you say it is 4 ohms plus some R infinity? Plus some R infinity? Everyone? Very good. So it cannot be less than 4 ohms. 100%. This option got eliminated. It can't be equal to 4 because there is some resistance here. 100%. This is also gone. Can it be 12? I don't think so, because I'll tell you why. Why it will not be 12. Look at the pink part. Look at that pink part of that circuit. Starting from that particular point, you have one 2 ohm, and then you have some resistances again over here. Then you have some resistances here, and some resistances here. So this part and this part, they both are in parallel. Can you see this particular part and this part? Between these 2 points, they are basically in parallel. So whatever happens, that final resistance should be lesser than each of the resistance. So this R infinity, or whatever this equivalent resistance is there, equivalent resistance is less than each of the resistance. That means it should be less than this 2 ohm, whatever you do. So this value can't go till 12 ohm and all. This has to be lesser than that 2 ohms. This has to be lesser than your 2 ohms. It can't be even more than 2 ohms. Got it? Everyone? Clear? So these 2 points, this point and this point, is here and here. There is one resistor here, and all these are in parallel with this 2 ohm. So 100% the total resistance in parallel will be lesser than each of these, which means it should be less than 2 ohm. So 100%, this can't be like 10, 20 ohms. It has to be 1 point something like that. So it will be more than 4. It can't reach 12 for sure. It can't reach 12. So it will be definitely lesser than 12. So D option. Without solving it completely, you can do the analysis. How many of you got the logic? Isn't it a beautiful conceptual question? Next one. Which of the following graph represents the resistivity with temperature for copper? Copper is a conductor. The reason why they have given copper is because it's a conductor. It's a conductor. And for a conductor, as temperature increases, resistivity increases. So obviously it should be option number B. No, it is not a straight line. It is going to be little bit non-linear. Remember, linearity exists only for a small range. For a decent amount of range, it is a non-linear curve. Yes, it will be non-linear. Only for a small range, it is linear. If this was a semiconductor, then it will be either a, yeah, it will be A graph. It will be A graph, because when temperature increases, resistivity decreases. It becomes more conducting in nature. So for copper, it will be this. For semiconductor, it will be option A. Cool. Moving on. Next question. Matrix, or basically match the following types. Two resistances, one of 8 and other of 24, are connected in parallel. This combination is connected in series with a 14 ohm resistance. Match the quantities. So first of all, draw the diagram. Without it, how will you proceed? 8 and 24 are in parallel. 8 and 24. This is 8 ohm. This is 24 ohm are in parallel. Their combination is connected with a 14 ohm resistance, and that together is connected to a 12-volt battery. First of all, can you find the equivalent resistance? I think these two together with this 14 ohm, 8 into 24 by 8 plus 24. Come on, guys, find out what that will be. 8 into 24 plus, 8 multiplied by 24 divided by 8 plus 24. Yes, come on. 8 multiplied by 24. 24 plus 8 is 32. 8 goes with 32 4 times. This goes 6 times. Just check it. If it is 6 ohms, so the equivalent resistance, equivalent resistance is 6 plus 14, which is 20 ohms. So the equivalent current will be voltage by resistance. 12 by 20 divided by 4 is 3, divided by 4 is 5. So 3 by 5 amperes is the total current. 3 by 5 amperes is the total current. Now you can start solving the entire thing. Come on, solve it. Yes. See how much are you getting. 6 ohms is the equivalent resistance of the parallel part. So A is with 3. So this part, though, we did it over here. This was 6, right? So A is with 3. A is with 3. It is there here. It is there here. So option B and option C are wrong. What about the other two? Resistance of the circuit. We just got it. What is the total resistance? 20. So the total equivalent resistance of the circuit, we just got it as 20. So B is with 1. B is with 1. B is with 1. Okay. So current in the circuit is 3 by 5, which is 0.6. 3 by 5, which is 0.6. Current in the circuit is 0.6. So C is with 4. This is wrong. So it should be option number A. Option number A. Yes, correct. Got it? Yeah, A for amps. 3 by 5 amperes is basically 0.6 amperes, guys. So such kind of questions can also come, which take up your time. Okay, next we have come to gravity, guys. Come on, guys. Let's do few questions of gravity quickly. Yeah, few more minutes, and then the remaining questions will be homework. The depth at which the value of acceleration due to gravity becomes n times the value at the surface. N times the value at the surface. Okay, the depth. The gravity at a depth is given by gravity at the surface 1 minus d by r. This has to become n times the value of the depth at which the value of the gravity becomes n times the value of the surface. So n times the value of the surface is g into 1 minus d by r. G gets cancelled, so n is equal to 1 minus d by r. So d by r is equal to 1 minus n, correct? So therefore, becomes n times the value at the surface. Nothing wrong over here. Perfect. So G gets cancelled. So 1 minus n is equal to d by r. So d, uh, yes. So d will be equal to r into 1 minus n. D will be equal to r into 1 minus n. Now I have a feeling they have made a mistake in the question. It becomes 1/nth or becomes reduces by n times. That is what they should have mentioned, because none of the options are matching as I can see. So I think there is a mistake in the framing of the question. Gravity usually, that's what I was thinking, gravity should reduce. Gravity becomes n times less, n times less, n times lesser than the value. N times it is reducing by a factor of n. Okay, I think that is what the mistake in the problem is. Gravity becomes less by a factor of n. So that is what it should have been. So actually, I think this should have been g by n. This should have been g by n. So then this will be 1 minus d by r. Therefore, g will cancel. So 1 by n will be 1 minus d by r. Therefore, d by r will be 1 minus 1 by n. Therefore, d by r will be n minus 1 by n. Therefore, d will be, take r on the top, n minus 1 by n. So then the answer will be B. Yes. So there was a mistake in the framing of the question. Yeah, there was a mistake in the framing of the question. So technically the question should be like the gravity gravity uh, becomes becomes less by a factor of n as compared to the value of the surface. That is how the question should have been framed. Okay, anyways, so I'll just remove this particular slide so that you know this would be the correct answer. Okay, cool. Let's go ahead to the next one. Which of the following represents the gravitational field at a distance r due to a shell? Field due to a shell, very similar to a electrostatics problem. So whenever you take a shell, okay, remember inside of it, it is zero. It is only when you go outside, the field becomes gm divided by r square. So 0 and then becomes 1 by r square. There is only one option like that, which is C. Yes. Yes. Everyone got it? Very good, very good, very good, very good, very good, very good. Yes. Option number C. Moving on. Okay. This is very similar to electrostatics. Nothing different. That's why we have coupled both the things together. The variation of acceleration due to gravity of two planets A and B are plotted as a function of distance r from the center. Which of the following statements are correct? Interesting. Come on. Who has more density? Who has more density that or same mass? That is what the question is. I can see the gravity at the surface is the same. At the surface is the same. I think one line is missing over there. One line did not get printed. Yeah, gravity on the surface is the same. And this is G naught, which is on the surface. And the gravity on the surface is given by Gm by r square. So clearly the radius of the shells are different. Radius of those planets are different, but m by r square is the same. So mass by r square is basically the same. And what is the mass? Mass is basically density into volume. So 4 by 3 pi r cube, the whole thing divided by r square is going to be the same. Now 4 pi 3 constants, r cube by r becomes r. So density into r is going to be the same. So density is inversely proportional to the radius. Density is inversely proportional to the radius. So who has smaller radius? Obviously A. So the radius of planet A is less. So density will obviously be more. So A will have more density as compared to B. Planet A has more density. Got it? As simple as that. So planet A has more density than B. Is this clear, everyone, till this point? Let me know. Somebody was asking why not A? A is not correct because see, inside it has to be 0. No? Inside it has to be 0 and outside it has to be inversely proportional to r square. Here, this is correct for a solid sphere. For a solid sphere, then the field is directly proportional to r. Here it is a shell. Shell. Shell means empty sphere. So that is why it is C. If it was a solid sphere, then the answer would have been A. Is that okay? Ninja? Absolutely. Yes, sir. Okay. Moving on. Next question. Come on, come on, come on, guys. Next question. Last few questions before we close the bell. Ring the bell. Close the class. Yes. Which of the following are true about acceleration due to gravity? G decreases when you move from the center. G decreases moving away from the center. G is 0 at the center. G decreases if Earth stops rotation on the axis. First of all, you just check this graph. Everything will be clear. Acceleration due to gravity versus the distance from the center. This is how it looks like. It goes like this and then goes like that. This is basically your surface. This is basically your surface. Now think and tell me. Gravity decreases when you move from the center. Gravity decreases outside the surface. R is more than R. That means this part. Yes, definitely gravity is reducing. It is reducing. So definitely statement 1 is correct. You can see it is right over here. Gravity is reducing. It is reducing. Gravity decreases moving away from the center. No, this is wrong. As you can see over here, as you go from the center towards the surface, gravity is increasing. Gravity is increasing, my dear warriors. So second statement is wrong. Why will gravity decrease if the earth stops? In fact, it should increase. This word decreases is wrong. It should actually be increases. It should actually be increases because centrifugal force will go away. So once the centrifugal force goes away, you will be pulled towards the earth in a better manner. So when you are getting pulled, that means gravity should increase. What about the last statement? What is it? Third, Gravity is 0 at the center of the earth. Oh, that is very clearly seen over here. Gravity is 0. So 1 and 3, which is option B. Yes, 1 and 3, which is option B. B for biology. Yep, correct. Moving on, next question. Inside a shell, gravity is 0. Oh, come on, this is very straightforward. Inside a shell, gravitational field is 0. Yes. Gravitational potential, not 0. In fact, it has to be constant. Gravitational field is same everywhere. Yeah, you can say that because it is 0 everywhere. The gravitational potential is same everywhere. Yes, that is what the B statement was all about. All of the above, how can it be all of the above when one of the thing is wrong? Yeah, so it should be A, C, and D, which is option B. B for biology. How many of you got it? Very good, very good, very good. Yeah, very good. Awesome, awesome. Great. Moving on, next question. The gravitational field due to mass distribution E is equal to A by x square is in x direction. A is constant, taking gravitational potential to be 0 at infinity. Potential at x will be. Okay, field is given, potential is asked. We all know that electric gravitational field is minus dV by dx. So E being given as A by x square, that is minus dV by dx. Moving things around, dV will be with a negative sign A into dx, and actually I can put x raised to minus 2 dx over here. X raised to minus 2 dx with a negative dV. Now obviously it's time to integrate it. Okay, limits will be when x is infinity, the potential is 0. When x is x, what is the potential? That's it. So minus dv's integration is minus v, or basically just v is the integration of dv. Then put the voltage as 0. Okay, so that's the left hand side. A into, great, x raised to minus 2's integration is x raised to minus 1 by minus 1. So x raised to minus 1 by minus 1, and minus infinity raised to minus 1 by minus 1. So what is this going to be? This will be minus v is equal to, because v minus 0 is v, a into, okay, minus 1 goes on the top, x raised to minus 1 is x below, minus minus 1, infinity is below, infinity is below. 1 by infinity is basically 0. So anything minus 0 is that number. Okay, anything minus 0 is that number. So this will just become minus a by x is minus v. So v will be basically a by x. V will be basically a by x, which is C option. That is correct. No, it is not B. Be little careful. It is C option. Cool. Let's go to the next one. The change in the potential energy when a body of mass m is raised to height height nr is how much? The change in the potential energy, which is final, which is minus gmm by the total height. The height is nr, so r plus nr will be the total distance, that is your final, minus initial, minus gmm divided by, just on the surface it will be r. So as you can see, gmm divided by r is common. With that negative sign, if you want, you can take it. So what do we have over here? You have 1 by 1 plus n minus I have taken outside common, so minus 1 by 1. That's what I'm seeing. So this, if you want, you can shift it inside and you will get gmm divided by r, and we'll have 1 minus 1 by 1 plus n, I believe. So this will be gmm divided by r. This will be nothing but n plus 1 minus 1 by 1 plus n after taking LCM. So 1 and minus 1 cancel. So n by 1 plus n in the brackets. But at options have g over there. Gm is nothing but g into r square. Gm is g into r square. So divided by r and multiplied by m, rr cancels. So mgr, and n divided by n plus 1. mgr n divided by n plus 1. That is C option. If you are wondering what just happened over here, let me tell you, Gm is gr square. How? Because G is capital Gm by r square. So that is why I can put gr square as Gm. So I've substituted that because I knew that formula. So very nice question. Final minus initial energy. I have taken minus Gmm by R common. So 1 plus n and 1 was remaining here. Then just did some simple math. Yeah. Is that clear? Okay. Arun, I'm not that energetic as before. Ayo, what to do? Responsibilities have increased, right? So that's the reason maybe. Yeah. Mentally, I'm very active, but physically, body also gives up, right? Because I'm taking care of NEET, JEE, Karnataka, Maharashtra, obviously all the South Indians or students, all the students from Northeast, and obviously a lot of students from Middle East are also watching these channels. That's why we are taking care of all these channels very, very sincerely, making sure that this becomes best channels. In fact, better than many of the Hindi channels also, I will say. Yeah. So a body is thrown with a velocity equal to n times the escape velocity. Velocity of the body at a large distance away will be what? Come on, come on, come on, come on, come on. What is the velocity of the body? Body is thrown with a velocity n times the escape velocity. The velocity of body at a large distance away will be how much? So over here again, imagine this is the surface, this is the center, this is the radius. From here you are throwing it uh, equal to n times the escape velocity. Won't it actually escape? So I feel something is wrong. I think it should have been n times less or something. Maybe there is a factor of 1 by n. I'm not really sure. They have made a mistake or something. Anyways, we'll take this as n times of v. So after it goes very, very far away, oh no, no, it's fine only. If it goes very far away, then it will still have some velocity, because if you throw it at escape velocity, after reaching a large distance, the speed will be 0. If you throw it more than the escape speed, it will still preserve some speed at a very far away point. So use energy conservation. So kinetic energy initial plus potential energy initial will be kinetic energy final plus potential energy final. Kinetic energy is half m, velocity is n times v. Potential energy will be minus gmm by r. Final energy half m v square plus potential energy 0, because when you go very, very far, the potential energy should become 0. Okay. So what happens now over here? Well, small m gets cancelled. N square ve square by 2 minus, now this will become minus gm by r is equal to v square by 2. V square by 2. That is what this is becoming. But we can convert that gm by r into something else. I'll tell you how. Escape velocity is root of 2gm by r. Therefore, ve square is 2gm by r. Therefore, gm by r is nothing but ve square by 2. Yes, to bring it down over here. So, gm by r technically is ve square by 2. That simplifies the problem. N square v square by 2. This is v square by 2. 2 to 2 cancels. ve square is obviously common here. And we have n square minus 1. This is equal to v square. So taking roots on both sides, v will be v root of n square minus 1. ve root n square minus 1. That is option labeled A. Yes, that is the correct answer. Got it, my dear warriors? Time period of satellite on the Earth is 24 hours. If the separation between the Earth and the satellite is decreased to 1/4, the new time period. Kepler's law, I can think of Kepler's law. Square of the time period proportional to the distance cube. So T1 by T2 is R1 by R2. this is cube, this is squared. First time, the time period was 24. Next time, I do not know how much it is. Decrease to 1/4. So this is 4 times, this is 1 time, cube. So this will be 24 by T 2 whole square is equal to 4 cube. 4 square 16, this will be 64. So taking square roots, 24 by T2 will be 8. So therefore T2 will be 24 by 8, which is 3 hours. Yes, 3 hours. Option D. Yeah, this is what happens. It's a sign of hunger, I think. Okay, great. So now the remaining questions, I think you can do it. I think some 5 questions are remaining, if I'm not wrong, 4 or 5 questions. Yeah, this is first question, second question, third question, 4, 5, 6. Okay, 7, 8, 9. Oh, many questions. 9 questions are there. Okay, so 9 questions, but I think they are very straightforward only. It is not that difficult. Please take it up as homework because I have another class right now on the paid batch. So I'll have to go there also. So thank you very much, guys. I'll be sharing the entire PDF. I will be, yeah, yeah, I'll be sharing the PDF for all of you. Yes, in the description box as well as in the comment section. So please check it out after the class is over. And do not forget to like the video, subscribe to the channel. And if you're not a part of the crash course, be a part of the crash course because the Vidya Utsav offer has been extended till 9th of March. So make the best use of the prices. Yeah, the crash course link is there in the description box. Okay, cool. Thank you so much, guys. Have a great time.